Hello students, welcome back to Math at Ease, and in this video I am going to take up the remainder and the factor theorem. Though the names sound really complicated and tough, the theorems are very easy. So without wasting much time, let me quickly move on to my whiteboard. So what exactly do you understand by remainder and factor theorems? Let me first take up the remainder theorem, okay? And then the factor theorem becomes very easy. Now, if you can relate them to long division or division of polynomials or normal numbers, remainder is the number or the term that is left down below when the division process is completed, okay? And when do you call a particular divisor as a factor? When you have the remainder as 0, okay? So now this is one particular theorem using which you can actually find the remainder without doing the long division process. Now what exactly does the theorem say? If you have p of x, if p of x is the polynomial, okay, whose degree is greater than or equal to 1, okay, and if p of x is divided by, that means the divisor is a linear polynomial of the form x minus a, okay, then the remainder is given by the value p of a. Okay, it may sound little complicated when you try to understand it using this general form, but it will become very easy when I take up examples and show it to you. Okay, it's actually very simple. Let me take up examples. Now I'll take up examples from the long division process video, so that I can also relate them using the long division process. Okay, so now I have taken this example. So I will try to find my remainder when this particular polynomial is divided by this. So my p of x is x plus 3x square minus 1, okay, and my divisor here is 1 plus x. Now according to the remainder theorem, it is given by x is equal to a. So what you have to do is, whatever is your divisor, 1 plus x, always equate it to 0, which will give you x as negative 1, okay, and this negative 1 is just like your a, p of a you will find. So you will find p of negative 1. That means wherever you have x, you will just substitute 3 negative 1 square minus 1, which will be negative 1 plus 3 is plus 2 minus 1 is 1. Okay. Now, so according to the remainder theorem, when this is divided by 1 plus x, I get it's similar to my x plus 1. This is the same, which I can relate to x plus a. Okay. And how do I find my that x plus a? So I always equate it to 0 to find the value of x. Okay. So that value we put here, p of negative 1, and my remainder is 1. Now what I'll do is, I'll try to show you the long division process what we had done before. Okay, so you will be convinced whether our answer is correct or not. See, this is the long division process, okay, and we got our remainder 1 here. So the remainder theorem actually saves lot of time. You don't have to do the entire long division, and you get the same answer using the theorem also. Okay, and how do you extend it to the factor theorem? If I had got my remainder as 0, then I will say that 1 plus x is a factor. But here in this particular question, my remainder is not 0. So I say that 1 plus x is not a factor of x plus 3x square minus 1. Let me take up a second example where I am actually getting it as a factor. So this is a second example. This is my second example where my p of x polynomial is x cubed plus 1. So my p of x is x cubed plus 1 is divided by x plus 1. Okay. So if I have to use the remainder theorem, I will always equate my divisor to 0. Okay, this is the first step. So that will give me x as negative 1. Okay. Now this particular value you have to substitute in your polynomial. Basically you need to find the value of your polynomial at x is equal to negative 1. So p of negative 1, which will be negative 1 cube plus 1, which is negative 1 plus 1, which is equal to 0. Okay, so you got p of negative 1, which is basically p of a according to the remainder theorem. It is giving you a value 0. Okay, so your remainder is 0. So in a way you can say that the given divisor is a factor of the given polynomial. So whenever the remainder theorem gives you 0, then it means the divisor is a factor of the given polynomial. And to get more convinced, let me take you back to the actual long division. This was the long division of the same thing, same question, and we got remainder 0. Okay. So basically factor theorem is an extension of the remainder theorem's result. If the remainder is 0, then it is a factor. If not, it's not a factor. Now I'll take a third example, a slightly bigger or tougher application type question of the remainder and the factor theorem. Now this is one question. Check whether the polynomial q of t, see, it can be any name and any variable. Okay, q of t, which is 4t cube plus 4t square minus t minus 1, is a multiple of 2t plus 1. Okay, so basically you have to find out if 2t plus 1 is a factor of the given polynomial. Now taking a long division method will become slightly longer. So what we can do is use the remainder theorem. Now for using the remainder theorem, what is the first step that you will do? You will take your divisor, which is 2t plus 1, and equate it to 0. Okay, which will give you 2t is equal to negative 1 and t is equal to negative 1 over 2. So you need to find the value of the variable by equating it to 0. And the second step will be finding the value of this polynomial at that particular value. So you'll find q of negative 1 over 2, which will basically give you the remainder. So we need to just substitute it carefully. Q plus 4 negative 1 over 2 square minus it's negative 1 over 2. You have to be very careful at these points, and then find the values. You're getting this value as 0. Okay, so your remainder is 0, which implies 2t plus 1 is a factor of q of t. That again implies that q of t is a multiple of 2t plus 1. So this is one application problem of the remainder and the factor theorem. Let me take up one more last question so that it will be clear to you. Now this particular question, what you see, is an application of the factor theorem. Now the question says find the value of k if x minus 1 is a factor of p of x, which is the polynomial kx square minus 3x plus k. Okay, but here they have already given us that x minus 1 is a factor. So we try to use the remainder theorem and apply the concept of the factor theorem. That means the remainder should be 0. Now if you can remember, how do we use the remainder theorem? We first use the divisor, which is x minus 1, and equate it to 0 to get the value of x. Here it becomes x is equal to 1, and then we try to find p of 1, which will be our remainder. Okay, but here p of 1 is equal to 0 as x minus 1 is a factor. Okay, so we find p of 1. Now we start substituting k 1 square minus 3 times 1 plus 1 and equate it to 0, which will give me k minus 3 plus 1 gives me minus 2 is equal to 0, which gives me k is equal to 2. Okay, so this is an application of the factor theorem. So this is how. Let me quickly go back to all the important points. So let us recall, if you are given a polynomial whose degree is greater than or equal to 1 and you are given another linear polynomial of this form, okay, linear polynomial will always be of this form, then you can always find the remainder without using the long division process using this particular method. What you do is you always equate the divisor to 0 to get the value of x, and then you find the value of the polynomial at that particular value of x, which is basically a. Okay, and whatever answer you get, p of a gives you the remainder. And an extension is, if this particular remainder is 0, then you can say that the given divisor is a factor of p of x or the polynomial. Okay, hope you understood everything, and if you want me to take up any particular topic, then do write in the comment section. Do not forget to subscribe my channel and like my video. Okay, see you in the next video. Bye bye.